Now I am making a video on work and energy of class 9 using my mobile. This is my mobile phone and I am doing something on the mobile phone. So I am doing some work because I am preparing a lesson. But this is not work in physics. And you are preparing for your examination and you are going through your notebooks, textbooks, and you're writing some formulas or you're by heading formulas or you're making or you're drawing some graphs and whatnot. You're doing everything for the preparation of examinations. So you're uh, doing much more work, but this is not work in physics. నేను ఇప్పుడు నా మొబైల్ ఫోన్లో వర్క్ అండ్ ఎనర్జీ అనే లెసన్ని ప్రిపేర్ చేస్తున్నా. నేను చాలా వర్క్ చేస్తున్నా, కానీ ఫిజిక్స్ ప్రకారం ఇది వర్క్ కాదు. అట్లానే మీరు కూడా ఎగ్జామినేషన్స్ కోసం ప్రిపేర్ అవుతున్నారు. ఎగ్జామినేషన్స్ కోసం ప్రిపేర్ అవుతున్న మీరు నోట్స్ చదువుతున్నారు, ఫార్ములాస్ రాసుకుంటున్నారు, గ్రాఫ్స్ ప్రిపేర్ చేస్తున్నారు, ఇంకా చాలా చేస్తున్నారు. కానీ ఇవన్నీ కూడా ఫిజిక్స్ ప్రకారము వర్క్ కిందికి రావు. ఫిజిక్స్ ప్రకారం వర్క్ జరగాలంటే, సో వర్క్ ఈజ్ టు బి డన్, దెన్ దెర్ షుడ్ బి ఫోర్స్. దిస్ ఫోర్స్ షుడ్ బి అప్లైడ్ ఆన్ ఎ బాడీ and that body must move, means it has some displacement. If these two things are there, then we say the work is done. And work is defined as the product of force and displacement. Suppose this is a wooden block. A person is pushing the wooden block with some force and it is moved to a distance yes. Then here the work done is given by W is equals to S. W is equals to F dot S, F into S, and other person is also doing some work, and this is a wall which is fixed, and this person is trying to is applying some force on the wall and he is trying to push the wall. His intention is to displace the wall. As the wall is fixed, he is applying much more amount of force for 2 to 3 hours and he tired. When he tired and he got sweat, in our daily life we call it as work, but in physics this is not work because there is no displacement. So here the work done is F dot S again, and force is there but displacement is 0, so total the work done is 0, means that this person has not done any work. ఇక్కడ ఒక పర్సన్ ఒక వుడెన్ బ్లాక్ ని డ్రాగ్ చేస్తూ అంటే పుష్ చేస్తూ నెడుతున్నాడు విత్ ఎఫ్ ఫోర్స్, అండ్ డ్యూ టు ది అప్లికేషన్ ఆఫ్ ఫోర్స్ దిస్ బాక్స్ ఈస్ మూవ్డ్ through a distance of s, so the work done is given by F into S. But this is the person who is applying force, a maximum force on a wall which is fixed, which cannot be moved, and the displacement of the wall is 0 even though he is applying much more force. And he applied, ఇతను 3 గంటలు 4 గంటలు ఈ ఫోర్స్ను అప్లై చేసిండు, చాలా అలసిపోయాడు, స్వెట్ వస్తుంది, మనం మామూలుగానైతే వీడు వర్క్ చేసిండని చెప్తాం, కానీ ఇక్కడ ఫిజిక్స్ ప్రకారం వీడు చేసిన వర్క్ 0. ఇట్లా మనం వర్క్ని డిఫైన్ చేయాలి. సో వర్క్ ఈజ్ నథింగ్ బట్ ద ప్రొడక్ట్ ఆఫ్ ఫోర్స్ అండ్ డిస్ప్లేస్మెంట్. So work is said to be done by a force on a body if it displaces the body in the direction of force. అంటే ఒక బాడీ మీద వర్క్ జరిగిందని చెప్పాలంటే ఒక ఫోర్స్ తోటి ఆ ఫోర్స్ని ఆ బాడీ మీద అప్లై చేసినప్పుడు ఆ బాడీ కనుక ఈ ఫోర్స్ వల్ల డిస్ప్లేస్ చెందితే ఇన్ ద డైరెక్షన్ ఆఫ్ ఫోర్స్ డైరెక్షన్లో డిస్ప్లేస్ చెందితే మనం వర్క్ జరిగిందని అంటాం. అండ్ యు నో వెల్ వర్క్ ఈజ్ ఈక్వల్స్ టు డబ్ల్యూ which is equals to F dot S, and the units of work is equals to force is measured in Newton in SI system and displacement is measured in meter in SI system. So the units of work are Newton meter, or in SI system it can be measured in joule, which is represented by capital J, as the joule is name of a scientist. If the units are named after scientists, then they must be given capital letters. For example, Newton is capital N and joule is capital J, ampere is capital A, and so on. Here meter is not the name of the scientist, so meter is just small m, and kg, k is kilo, which means 1000, and g is grams, so all are small. Second, s is small, like that. So here joule as the name of the scientist, so it should be capital J. How you define joule? If 1 Newton force is applied on a body and body moves 1 meter in the direction of force, then work done is 1 joule. ఒక బాడీ మీద 1 న్యూటన్ ఫోర్స్ అప్లై చేసినప్పుడు అది కనుక 1 మీటర్ డిస్ప్లేస్ చెందితే ఫోర్స్ డైరెక్షన్లో అప్పుడు జరిగిన వర్క్ని 1 జౌల్ అని అంటాం. ఇఫ్ ఏ ఫోర్స్ has component in the direction of displacement, then we say the work is positive. If the component is opposite to the direction of displacement, then we can say the work is negative. For example, consider the same one, that a person is moving a wooden block. He is applying force in this direction and the block is moved in the same direction, and the displacement is there in the direction of force. Then we can say the work is positive. ఇక్కడ ఒక పర్సన్ ఈ బ్లాక్ని మూవ్ చేస్తున్నాడు, ఫోర్స్ను ఈ డైరెక్షన్లో అప్లై చేస్తే డిస్ప్లేస్మెంట్ కూడా అదే డైరెక్షన్లో ఉంది, ఉన్నప్పుడు ఆ వర్క్ని మనం పాజిటివ్ వర్క్ అని అంటాం. అలా కాకుండా నౌ a person want to stop the ball with his hand. Ball is in this direction, ball is moving in this direction. So to stop this, he must apply the force in this direction. So the ball will hit his hand and he apply force in this direction. After hitting, the hand will move a little bit in this direction, so the ball has displacement in this direction. ఇప్పుడు మనం ఈ బాల్ని ఆపాలని అనుకున్నాం, సో చేతిని అడ్డు పెట్టి దాని మీద ఎఫ్ అనే ఫోర్స్ని అప్లై చేస్తే ఆ బాల్ ఆగుతుంది, కానీ బాల్ వెంటనే ఆగదు, ఆగకుండా చేతితో పాటుగా కొంచెం వెనుకకి వెళ్తుంది. దిస్ హ్యాండ్ విల్ మూవ్ బ్యాక్ with some displacement, and let it is ds. Then the work done in this case, force is in this direction and the displacement is in this direction, this work done is negative. Take one more example. This is ground and the ball is given some motion on the ground. After some time the ball will stop because of the application of frictional force. Frictional force is always opposite to the motion of the ball, motion of the body, so the force will be in this direction, but ball will move a distance and then it stops, so the displacement will be in this direction. This is called negative work. And one more example, ball is projected vertically up. ఈ బాల్ని మనం వర్టికల్గా ప్రొజెక్ట్ చేసినాం బయటకి, then there will be displacement in this direction but the force will be in this direction, which is gravitational force. So the work is negative. While coming back, the ball will displace in this direction and the force will be in this direction. Then it is పాజిటివ్ వర్క్. కిందికి తిరిగి వస్తున్నప్పుడు బాల్ యొక్క డిస్ప్లేస్మెంట్ ఈ డైరెక్షన్లో ఉంటుంది, ఫోర్స్ కూడా గ్రావిటేషనల్ ఫోర్స్ కూడా ఇదే డైరెక్షన్లో ఉంటుంది, కాబట్టి ఇటువైపు ఉన్నదాన్ని పాజిటివ్ వర్క్ అని అంటారు. లెట్స్ సాల్వ్ దిస్ ప్రాబ్లమ్. క్యాలిక్యులేట్ ద వర్క్ డన్ on the body by a force of 500 Newton and it moves 7.5 meter. While solving any problem, first you have to write the data given, and the force is given as force is F is equals to 500 Newton and displacement, how much it is moved. So this is S is equals to 7.5 meter. So we have to find out the work done. The work done is given by the product of F and S. W is equals to F dot S. As these are moving in the same direction, F is 500 and S is 7.5. So it will be 3750 Newton meter, or you can write it as 3750 joule. Here one more question is given. Find out the magnitude of force. Work is given as 100 joules and the displacement is 5 meter. Find out the magnitude of force acting on a box when 1000 joule of work is done to displace it by 5 meter. Again, you have to write the data given the work done on the box. Work done, which is given by W, is equals to 1000 joule, and the displacement is given. Displacement S is given as 5 meter, and what you have to find? You have to find force. F is equals to what? So we have W is equals to Fs, implies W is 1000 is equals to F, we have to find out, and this is given as 5. From here, F is equals to 1000 by 5. 5 ones are 5, 2s are 0, 0. So F is equals to 200, as the work is in joules, SI system, and displacement is in meter. Again, it is in SM system, so force should be in SI system. So it is force is equals to 200 Newton. Calculate the work done by a person in lifting a load of 20 kg from the ground and placing it on 1 meter high on table. You have to understand the question first. Here one table is there and a 20 kg load is on the ground. The height of the table is 1 meter. The person is lifting this one and keeping this on this table, and again you have to write the data given. Here the load of 20 kg. 20 kg means mass is given. Mass of the load M is equals to 20 kg, and the person lifted it for 1 meter. So the displacement is 1 meter. So we have to find out the work done. Work done is given by F dot S, but here the mass is given. So you have to find out force first. The force, we are doing the work against the gravitational pull. That's why the force should be equals to mg. Means this formula becomes F is equals to mg and the displacement is S, and implies W is equals to mass is given as 20 and value of g is 9.8 meter per second square, and S is height is 1. again implies W is equals to 20 into 9.8 implies W is equals to the work done is 196 joules. Kinetic energy is the energy possessed by an object due to its motion. Capacity of a moving thing to do work. Energy is capacity to do work. If the object is moving, then we can say that energy as kinetic energy. Here one example is given: when a football player hits the ball or kicks the ball will move in forward direction because of gaining of kinetic energy. In similar way, a moving car have kinetic energy, or flowing water or flowing river has kinetic energy, and a bullet fired from gun has kinetic energy. Fired bullet is also have kinetic energy, and many more examples are there in our daily life. I am going to derive expression for kinetic energy. Consider a ball of mass m is there on a smooth surface, and a force F is applied on it, so that it displaced through a distance of s, and its velocity changes from u to v. Means initial velocity is u, final velocity is v. I am writing all the things. Applied force is F, displacement is s, velocity, initial velocity is u, and final velocity is v. We have work done, W is equals to F dot S. So the work done by the force is given by W is equals to Fs. In place of F I can write ma. Due to the force it got acceleration, that's why its velocity is changed. And here I have S again, and I can replace S with equations of motion. You have v square minus u square is equals to as. From here S can be written as v square minus u square by 2a. So S is v square minus u square by 2a. This a cancels each other. So W is half m into v square minus u square. This expression is the work energy theorem. At this work, capacity of moving things to do work is kinetic energy. So this work can be taken as kinetic energy and is equals to half m into v square minus u square. If the body is at rest initially, before application of force, let the body is at rest. That means u is 0, so that this equation becomes kinetic energy Ke is equals to half m. In place of u, please keep 0, 0 square is 0, so it is half mv square. This is the expression for the kinetic energy. Potential energy, this is the energy possessed by an object due to its position or shape. Here are some examples: compressed spring, a body raised to certain height, an object raised to certain height, or stretched rubber band, and water stored in dam, and many more are there. For example, if you take a compressed spring, This is a spring which is not compressed initially. Now this spring is compressed. Then the work done to compress the spring is stored as potential energy in the spring. And if you keep a thermocol ball which is very small, and if you release, then the ball will move. This is because of the potential energy stored in the spring. In similar way, a body is raised to certain height. So here the work is done against the gravitational force. So this work done is stored as potential energy in this object. Expression for gravitational potential energy. Consider an object of mass m is on the ground. Now it is raised to a height h. To raise this body to a height h, some work is to be done against the gravitational pull, gravitational force, and that work is equals to force into displacement, and this force is given by mg. Actually you have F is equals ma. Here a is equals to g. Here a is equals g, where g is acceleration due to gravity. So it will become mg, and the displacement is from here to here, so this is h, and this work done is equal to mgh, and this work done is stored as potential energy in this object when it is raised to height h. Then potential energy is given by mgh. One problem is given here. Calculate the potential energy of a body of mass 8 kg raised to a height of 5 meter. For our calculation to be simple, consider the value of g as 10 meter per second square. Actually, the value of g is 9.8 meters per second square. Now I am going to write the data given. Mass of the body, which is m, is 8 kg, and it is raised to a height of the body, or h, which is equals to 5 meter. We have to find out the potential energy. Potential energy formula is mgh. So we can keep in the place of m it is 8, g is 10, and it is 5. This is 400 joule. Here is a problem. A bicycle rider along with his bicycle has a mass of 80 kg, and he is pedaling the cycle with a speed of 8 meters per second. So we have to find out the energy. As the body is moving with some speed, it must have kinetic energy. So in this problem, we are going to find out the kinetic energy of the system. First, the data given should be written. Mass is given. Mass m is equals to 80 kg, and the speed or velocity v is given as 8 meter per second. Formula for kinetic energy is half mv square is equals to half into mass is 80 into v square is 8 square, implies kinetic energy is equals to half into 80 into 8 square is 64. 2 ones are 2 fours are 8, and 0 implies kinetic energy is equals to 4 fours are 16, 4 6 are 24, 1 2 5 6, and 0 is there, so it is 2560 joules. Here is a question. A machine gun bullet of mass m leaves the barrel with a speed of 100 meter per second, and the kinetic energy of the bullet is 1000 joules. What is the mass of the bullet? And the data given is speed of the bullet, which is v is 100 meter per second, and kinetic energy of the bullet Ke is equals to 1000 joules. Mass is given as m. We have kinetic energy is equals to half mv square. Substitute the things. So kinetic energy is 1000 is equals to half m should be find out, and v square, this is 100 square, implies m is equals to 2 into 1000 by 100 square, which is 100 into 100. Two zeros, and this 0 cancels, and it will become m is equals to 2 by 10. 2 by 10 is nothing but 0.2. All are in SI system, so it is mass is 0.2 kilograms. Conservation of energy. Energy can neither be created nor be destroyed, but it can be converted from one form to other, and the total energy of the system always remains constant. For example, the chemical energy in a battery converts to light energy or electrical energy, and the electrical energy in a bulb converts to heat and light energy. Conservation of mechanical energy. Mechanical energy is sum of potential energy and kinetic energy. So we have to prove in any system the sum of potential energy and kinetic energy is constant. To prove this conservation of mechanical energy, this is a simple pendulum. Simple pendulum consists of a metallic bob, and this metallic bob is attached to a thread, and this system is hanged from a fixed support. This simple pendulum is dragged to point A, and it is left for free oscillations, and the simple pendulum makes oscillations from A to B to C and comes back from C to B to A. If the height at A is h, the height at C should be h, and the velocity here is 0, and here also the velocity is 0. So we have to find the total energy at point A, point B and point C. Consider at point A, here the kinetic energy is equals to half mv square, but the velocity is 0, so it becomes 0, and the potential energy is mgh. As the height is h, it is mgh, so the total energy at A is equals potential energy plus kinetic energy, so it is mgh plus 0, which is equals to total energy at A is equals to mgh. Now at point B, here the height is 0, so the potential energy, which is equals to mgh, as height is 0, mgh will be 0, and kinetic energy is, let the velocity here is v, so it is equals to half mv square. We have one equation that v square minus u square is equals to as. As the pendulum is coming from here, the initial velocity is 0, so v square becomes, v square is equals 2 into g into s. In place of s, the height is equals to h. So we have to keep h here because the distance traveled by the bob is h. Then kinetic energy becomes half m into v square. V square is equal to 2gh. This 2 gets cancelled and kinetic energy is equals to mgh. Now the total energy at B is sum of potential energy and kinetic energy, which is equals to 0 plus half mv square. Here half mv square is converted to mgh, so it is equals to 0 plus mgh. Finally it is mgh. Total energy at B is mgh. Consider point C. At point C the height is h, so potential energy will be there, and the potential energy is equals to mgh, and the kinetic energy, as it is the maximum point, so the kinetic energy is 0 as velocity is 0, so it is half mv square, but velocity is 0, so it becomes 0. So the total energy at C is equals to potential energy plus kinetic energy, which is equals to mgh plus 0, which is equals to mgh. So total energy at A is mgh, B is mgh, and C is also mgh. So we can say the mechanical energy is conserved. Consider one more point. So this is the point which is called D. It is at a distance of x from C. So the distance between this point and this point is h minus x. Now I am going to find out the total energy at point D. As the body is moving here, it has some velocity. Let the velocity is v1. So the kinetic energy will be half m v1 square. Using the equation v square minus u square is equals to as. We can write v1 square minus u square. Here the velocity is 0. So 0 is equals 2 into g into the distance from here to here. We have to consider the vertical distance, so it is equals to x. So kinetic energy becomes, kinetic energy is equals to half into m into 2gx. This 2 cancels each other, and kinetic energy is equals to mgx. Now consider the potential energy. Potential energy is actually mgh, where h is height. Here the height is, the point is here, so it is from h minus x height from this point. So potential energy is equals to mg into h minus x. So the total energy at D, total energy at D is equals to potential energy plus kinetic energy, mg into h minus x plus kinetic energy is mgx, implies total energy at D is equals to mgh minus mgx plus mgx. This minus mgx, this plus mgx gets cancelled, and total energy at D becomes mgh. If you consider any point in its journey from here to here, so the energy is always mgh. So we can say the mechanical energy is conserved in any system. Here one problem is given: an object of mass 1 kg is falling from the height h is equals to 10 meter. What is the total energy at height 10 meter, and potential energy at height 4 meter, and kinetic energy at the same height, and we have to find the speed of the object when it hits the ground. Here assume g is equals 10 meter per second square. For our convenience, if you take 9.8, the calculations will be a little bit complicated. So consider the G value as 10 meter per second square. The total energy at height 10 meter. As it is falling from the height 10 meters, it is falling from the height 10 meters, means the velocity here is 0 and the height is 10 meters. So at 10 meter height, the object have only potential energy. So the potential energy is given by the formula mgh. So mass is 1 and g is 10 and height is again 10. So it is equals to 100 joules, and kinetic energy is 0 because the velocity is 0. So the energy at this point is equals to total energy, which is equals to potential energy plus kinetic energy, and 100 plus 0 is equals to 100 joules. So the total energy here is 100 joules. And second question is potential energy at the height 4 meters. So this is very simple. So B, here the height is just 4 meter and potential energy is mgh again, which is equals to mass is 1 kg and g is 10 and the height is 4, which is equals to 40 joules. And third question is kinetic energy at the thing. So at any point in its journey, the mechanical energy is conserved. So here the potential energy plus kinetic energy should be equals to 100 joules, because 100 joules is the energy here. So 100 joules should be at every point in its journey. So 100 joules means at this point potential energy is 40 and kinetic energy that has to be find out is equals to 100 joules, implies kinetic energy is 100 minus 40, which is equals to 60 joules. You can calculate this in other way by finding the velocity here. In this point you can find out the velocity. That velocity is given by v square minus u square is equals to 2as, implies v square is equals to u is 0 because it is the starting journey is from here. So u is 0, v square is equals 2 into 10 into, and yes, height from here to here it is 10 minus 4, it is 6. So 60 into 2 is 120. So kinetic energy is half m v square is equals to half into, in place of m it is 1 because mass is given as 1 kg, and v square is 120. 2 ones are 260. So kinetic energy is 60 joules. This is the other way to find out the kinetic energy. This is also a way. Here we used law of conservation of mechanical energy. Here you use formula. And the fourth one is speed of the object when it hits the ground. When it hits the ground, it only have kinetic energy. There is no potential energy because the height is 0 here. So kinetic energy will be 100 joules because 100 joules will be here, and each and every point of its journey the energy is 100 joules. As potential energy is 0, the total energy is kinetic energy, and kinetic energy is 100 joules, which is equals to half m v square is equals to 100 joules, implies m is 1 into v square is equals to moves that side, so it is 200, implies v is equals to under root of 200, implies v is equals to 225. So 15s are, so 225, so it's approximately equals to 14 meter per second. 14 point something will come, so approximately we can take it as 14 meter per second. In this way you have to solve the problems given on conservation of mechanical energy. Power This is rate of doing work. Two persons are given the same work, and the person A completes the work in 10 minutes. The same work is completed by the person B in 12 minutes. Then we can say the power of A is more compared to B because he completed in lesser time compared to B. So the definition should be rate of doing work. You know well, when in a definition, if rate is there, then the time should be in the denominator doing work. So work should be in numerator. So the power is given by work by time or the work done in unit time. The units for power is joule per second because work is measured in joules and time in second. This joule per second also called as watt is given by capital W, and this watt is defined as if 1 joule work is done by an agent or a machine in 1 second, then the power of the machine is 1 watt. One problem is given here. Person A does 500 joules of work in 20 seconds and person B 750 joules of work in 25 seconds. Who delivers more power? First of all, find out the power of person A. Here the work done by person A is 500 joules and the time taken by him is 20 seconds. So the power is W by T, which is equals to 500 by 20, 0, 2 ones are 225. So the power delivered by A is 25 watt. Now the power delivered by person B. The work done by him is 750 joules and the time taken to complete the work is 25 seconds. So the power is again W by T, which is equals to 750 by 25. 25 ones are 25 threes are and 0. So it is 30 watt. So the power of B is 30 watt. By this you can say the power delivered by B, PB, is greater than power delivered by A.